Okay, then we're going to do this last example here. Number 8, find all solutions of 2 minus sine squared x equals 2 cosine squared x over 2. So this is an equation where we've got both x and x over 2 in it. So 2 minus sine squared x equals 2 cosine squared x over 2. And we want to find all solutions of this. So the first thing we have to deal with is the fact that we have an x over 2, a half angle, and an x, just a regular angle. And we're going to deal with that with our half angle formula. So I'm going to replace the cosine x over 2, theta over 2, same thing, cosine x over 2 with this. So this would be plus or minus square root of, and it's 1 plus cosine theta, or 1 plus cosine x in this case, over 2. That's what cosine x over 2 is. Now it's cosine squared, so this whole thing has to be squared. And then rewrite everything else. Okay. Plus or minus square root of 1 plus cosine x over 2, that's squared. When that's squared, the plus or minus goes away, because either way, squared, it's going to come out positive. The square root sign goes away. So now I have 2 times 1 plus cosine x over 2 here. The left side of my equation remains the same. I've got 2 over 1 times this over 2. The 2's can cancel, and I've got 1 plus cosine x. Go ahead and bring the left side down. Oops, 2 minus sine squared x. Now, again, we're solving for x. So this is a find the solutions type of problem. But this is something that we've saw. There was a problem like this almost exactly on the quiz. Where now our problem is we've got both sine and cosine, but that we've dealt with those kind of problems before. What we do is we take our squared one, sine squared, and we replace it with what it is in terms of cosine, which is 1 minus cosine squared x. So that's 2 minus sine squared, which now we've written as 1 minus cosine squared x. Only thing left to do is to distribute the negative. So minus 1 plus cosine squared x equals 1 plus cosine x. Now we're going to push everything to the left, to one side of the equation, and put it in standard form. So cosine squared x minus cosine x, just brought this guy over, minus 1. Well, let's look. Here we have 2 minus 1, which is 1, and then subtracting this 1. So that's just all the constants, 1, negative 1, and 2, they just add to 0. 2 minus 1 is 1. Subtract the 1 from here, that's 0. So this is what we end up with. Now we need to solve this for x. So again, we've seen this before. We're going to factor out a cosine x. Left with cosine x times cosine x minus 1 equals 0. Can use the 0 product property to split this up. Cosine x equals 0. Cosine x minus 1 equals 0. That's cosine x equals 1. Almost done. We know what cosine x equals, but we want to know what x equals. So let's start with this one. Cosine x equals 0. That works whenever x is pi over 2 and 3 pi over 2. Cosine x equals 1 when x is 0. 2 pi, but I'm going to write it as 0. Now they want all solutions. If you look here on the notes, it said find all solutions. So that means that we've got to write the plus 2 pi in to cover every single possible angle that works. And really, there's no reason to write the 0 plus 2 pi in. You could write that as just 2 pi in there, but if you want to write the 0 plus 2 pi in for consistency with the other ones, that's fine. So anyway, there's your answer. Let me remind you kind of what we did. We started with something that had a double or a half angle in it and a regular angle. We replaced it with the identity squared it, did some simplification. We ended up with this equation, which had both sine squared and cosine x in it. We replaced the sine squared with 1 minus cosine squared and got it as basically a quadratic that we could factor and then use the zero product property and then get our cosine x equals and then get our solution. And there's our solution right there. Guys, thanks a lot for listening. The homework for this lesson should be on the screen, and it's also in the email I sent you. Have a good weekend, stay warm, and I will see you on Monday.